Alright, this is the review for the retake. Sorry, I should erase that first. This is the worksheet that we've already done, but it's good practice, and it's very similar to what's going to be on the retake. So, looking at the first example, we need to find the slope of each function and then compare them. Whenever given the slope of a graph, you're going to count rise over run or change in y over change in x. So I count my y, it's down 4, so that's negative 4. I count to the right, it's right 3, so that's positive 3. Slope is change in y over change in x, which in this case is negative 4 over 3. Negative slopes slope downward when you go from left to right, so I'm comfortable with the positive or negativeness of this. Negative 4 over 3. On function 2, we need to solve for y, so we're going to subtract 20 from each side. These are not like terms. There's some people that continue to make this mistake. They do not combine. So this is just 5y equals 10x minus 20. And now we need to divide, and when we divide every little part. So if you divide the whole side, you divide each part split up by addition or subtraction. The final result is y equals 10 divided by 5 is 2, 20 divided by 5 is 4, and the slope is the number in front of x. Function 3, we need to find our change in y. So from negative 4 to positive 4, I go to 0, which is 4, and 4 more, which is 8. Or you say 4 minus negative 4 is 8. Second minus first. This should be clear that it's down 6. From 4 to 8 is up 4. That should be clear, I hope. This is down 3. Slope is change in y over change in x. So we'll put your y number first, your x number second. We could have used the 4 and the 3 as well. This reduces to 4 over negative 3. So same as the first, negative 4/3. And when I get to the question which function is steepest, the second function is the most steep. It has a value of 2. You would plug in your calculator. These values are negative 1.3, negative 1.3, exactly 3 repeating, but if you want to say approximately, that's fine too. But if you need to pause and get caught up, go ahead and do that now. I'm going to move on to the second question. All right, the second question is asking about whether something is linear or not. This should be very clear that it's not linear. To be linear, it would need to have a straight line. The middle example, we can see if the slope is constant. So the change in y is plus 2. The change in x is minus 4. Again, plus 2 in the y. How do you go from negative 2 to 0? You add 2. How do you get from 1 to negative 3? You subtract 4. Plus 2. Minus 4. So these numbers are all the same, so this slope is constant. This is linear. The numbers don't have to be the same. What has to be true is that the relationship has to be the same. So 2 over negative 4 would have to equal the relationship of the middle. 2 over negative 4, which would have to equal the relationship of the bottom. Since all 3 of these are equal, that means it's linear. And it would be the reduced form, but we didn't need to reduce because they're all the same. The first one is the trickier one. Those of you that know your rules recognize with an exponent of 2 it's not linear. So there's a few tricks on not linear, and I'll just remind you of them here. So exponents bigger than 1 are not linear. Dividing by x. Dividing by x or y is not linear. Multiplying x times y is not linear. So these three are nonlinear choices. Nonlinear functions. There are other rules, but these are the most common. An exponent bigger than 1, dividing by x or dividing by y, multiplying x and y are all nonlinear. All right, I'm going to go ahead and go to the next one. If you need to pause, go ahead and do so now. All right, number 3, this says identify the x and y intercepts from the given graph. Express the intercepts as ordered pairs. Some of us struggled with getting these as ordered pairs. So the intercept means crosses. So we want to know where it crosses the x-axis and crosses the y-axis. Well, the x-intercept crosses the x-axis at this point here. So this is the point x equals 3, so your x-coordinate is 3. But remember, it's still an ordered pair. It's 3, 0. So to write it as an ordered pair, we write 3, 0. The y-intercept is where it crosses the y-axis. In this case, it's -3. But that's the y-coordinate. So the x-coordinate is 0. When we're on the y-axis, it's 0 left or right. So we need to write this as 0. -3 in this case. And those are the intercepts as ordered pairs. We do this to help us graph using the cover-up method. We're going to see that in number 4. If you need to pause, go ahead and do so now. So in number 4, we're going to graph, and I would recommend using the intercepts to graph. You could solve for you could solve for y, excuse me. To solve for y, I don't think this is the fastest way, I don't think this is the easiest way, but there are some students that had a lot of success doing this, so I'm happy to show you. Remember, the 12 and the 2x are not like terms, they are apples and oranges, you cannot combine them. When I divide by the 6, I have to divide every little part. It's dividing both sides by 6. And we get y equals, this reduces to 1/3 x minus 2. So you could graph it using slope-intercept. But we more often did cover-up. So here's the cover-up method. If I have -2x plus 6y equals -12, when I say x is 0, I'm just left with 6y equals -12 and y equals -2. So this is the y-intercept, 0, -2, and I graph it. Notice that's your intercept in y-intercept form. If I have -2x plus 6y equals -12, and I say y is 0, then I'm left with -2x equals -12, divide, and x equals 6, which is the point 6, 0, which is over here on the x-axis. Again, you can pause at any time. So to graph this, we connect those two dots and do the best we can to keep it straight. And there's the graph using intercepts. Notice that from -2, if you go up 1/3 and up 1/3, you do the slope twice, you end up at the intercept. So you can graph it using slope-intercept as well. I'm about to go on to 5, so if you need to pause it, go ahead and do so now. All right, for the most part, we did pretty well on number 5. There's 2 or 3 people that are not understanding what function notation is. All function notation does, this doesn't change. So whatever I do to this equation, f of negative 2 stays f of negative 2 on and on and on and on. Okay, you don't need to write that down. That never changes. That 2, the job of that 2 is to tell you what x is. This is just saying x equals negative 2. So when I say f of negative 2, I need to replace x with negative 2 and then simplify. You can do this on your calculator. 9 times negative 2 minus 6. Well, 9 times negative 2 is negative 18, minus 6 is negative 24. So a good way to write it in its final form is like this. Again, the negative 2, it stays. Please don't do anything with this. It stays, it stays, it stays. Okay? The next one. This is just saying x equals 1/4. So you're going to plug in 1/4. You're going to substitute. Substitute 1/4 for x. And this one has some fractions. It's not as friendly, but that's okay. F of 1/4, that will not change. It'll be f of 1/4 to the end of the problem. But over here, I'm going to replace x with 1/4. Please use your calculator. 9 times 1/4, you can write it as 9/4, or you can write it as 2.25. If you do your calculator, 9/4 minus 6. 6 is 24/4. And you end up with 15/4. Negative 15/4. If you do it as the decimal, you get negative 3.75. Decimals are fine for me as long as you can express it correctly. So function notation, we're just plugging in for x and simplifying. These should be easy points for us. Please make sure you know how to do this before the retake. All right, I'm going to pause the video and start another one.